Welcome everybody to this short bite-sized session on mixed fractions. What we're going to talk about today in the session is to talk about something called improper fractions. So I've just said we'll look at mixed fractions, but we need to understand and recognize what improper fractions are first. We'll then talk about how you convert those improper fractions to whole numbers or mixed fractions. And then we're going to look at how you add or subtract using mixed fractions. At functional skills level 2, and there is no requirement for you to divide or multiply mixed fractions. You might be pleased to know. So I'm only going to focus on adding or subtracting. If you want to know how to do any more than that, then we can cover that afterwards and separately with you. But we will look at adding and subtracting for today. So fractions look like that. They're a number on top of another number. The top number is known as the numerator. The bottom number is known as the denominator. You don't need to use those terms. You don't need to necessarily know those terms, and I won't use them probably for the rest of the presentation, but it's just useful to know that they do exist. And what we normally see with fractions is the top number is lower than the bottom number. So if we take the one on the left there, it's 2/10, 2 out of 10, means we've got 2 parts out of 10. Let's look at a really simple example. A lot of things involving fractions involve cake, pizza, pie, those kind of things, but I thought I'd mix it up and we'll go with donuts. So we've got a donut there on the left-hand side that's split into 4 parts. And if you split something into 4 parts, we call them quarters. So this donut is split into the quarters. And if I took one of those pieces, it would be a quarter, which we would write 1/4 like that in red. And that's how we write 1/4. And obviously, if we've got the whole donut as well as one whole donut, we could say that it's 4 quarters. So there are 4. The donut is cut into 4 separate pieces. And if we ate it all, we've eaten all 4 of those parts. So we write it as 4/4. We wouldn't normally write it like that as a fraction. We would just say that we've eaten the whole donut. But we could write it as a fraction of 4/4. If we're talking about improper fractions, however, let's say we've got more than one donut, and let's say we've got 3 donuts. We've still cut them into quarters, and we're actually going to take and eat all of these donuts, which apart from not being good for you, but is useful for a maths explanation. So this time what we've done is we've eaten 4 quarters there, and 4 quarters there, and 4 quarters there. So we've actually eaten all of the quarters. So the donut was still split into quarters, and we've eaten 4 of them, and another 4 of them, and another 4 of them. And when you add up fractions such as that, what you do is we keep the bottom number the same, so it's still out of quarters, and we've eaten 12 quarters. And this is now an improper fraction, because this is where our top number is higher than our bottom number, which is not the way we normally do fractions, so it's an improper fraction. A proper fraction would have a lower number at the top, so an improper fraction has the higher number at the top. And it's still accurate. We would normally say that we've eaten 3 donuts, but actually we could say we've eaten 12 quarters of donuts, which might make us feel a little bit better or worse, I'm not too sure. So that would be an improper fraction. So let's take that as an example. We've got 12/4 as our improper fraction. Let's have a think of another improper fraction. So that number at the top is higher than the bottom. What if we'd eaten 6 halves? So when we've got something over 2, we call them halves. Let's say we've eaten 6 halves. I'll give you a few seconds to think about what that might mean as a whole number. So if we've eaten 2 halves, that would be a whole one. We eat another 2 halves, so that's another whole one. And we've eaten another 2 halves. So we've eaten 6 halves. So 6/2 is the same as 3. 6 halves would be 3 whole ones. Think of the same principle now for 21/3. I'll try and move away from donuts. So let's say we've got anything that's split into thirds, and we've got 21 of those thirds. So how many whole things have we got there if we've got 21 thirds? Well, I can tell you the answer is 7, and one way to check that, if we do 7 times 3 would give us 21, or we could do 21 divided by 3 gives us 7, or we could draw it out and we could draw thirds, and if we drew 21 thirds and put them into little 3s, so we've got whole ones, we would end up with 7 whole ones. Slightly more difficult question though, hopefully you might think that, is what if we had 16 thirds? So we've got something that's split into thirds, and we have 16 of those pieces. How many whole ones have we got, and are there any issues with this number? Give you a few seconds to have a think about it. Okay, so I'm going to go back to pizzas now, just because it is a little bit easier. So let's say we've got a pizza cut into thirds, and we put those 3 together, and we've got back to our whole pizza. So we've got 3 pieces there. We've got 6 pieces, 9, 12, 15. So we can put those 15 pieces of pizza back in, and we end up with 5 whole pizzas. Our improper fraction was 16 thirds though, so there's 15 pieces there, and we've got 1/3 left over. So we look at the bottom, 3, 6, 9, 12, 15, and 16. What we've actually got there is 5 whole pizzas, and we've got 1/3 left over. So we write that as 5 1/3. And 5 1/3, you might be pleased to know, is an example of a mixed fraction. So a mixed fraction is simply where there's a whole number part and a fraction part. A whole number, in this case 5, and a fraction part, in this case we've got a third, and some of the examples there, 1 1/2, 2 1/3, whatever it might be. So an improper fraction, if I just go back, is where you have the higher number at the top and the bottom. We can convert that into whole numbers, but sometimes, like our final example, we need to convert it into a mixed fraction, which is a whole number and a fraction part. So that's simply what a mixed fraction is, where you see a number and a fraction part. I mentioned at the start, there's two things we need to be able to do with mixed fractions for functional skills level 2, and that's to add or subtract them. I'm going to work through one example on the screen, and then I'll talk through the stages that we go through. So I'll work through this example first. And the example I'm going to have is 4 5/8 add 2 6/8. So that's our calculation. I want to work out what is 4 5/8 and add 2 6/8. There are a couple of different methods of doing this, but the first one I would recommend is let's take out the whole numbers. So we've got the whole number 4 and we've got the whole number 2. We're adding things together, so we're going to add them together, and that gives us a number 6. I'm just going to park that on the side there. And the reason we've done that is we can deal with whole numbers quite easily, and we can do 4 add 2 quite easily. So let's move them out of the way, and then makes life a little bit easier for us. So let's get rid of our 4 and get rid of our 2. And what we're left with now is 5/8 and 6/8. Now we have got a separate recording on working with fractions that go through how you add fractions. So I'm not going to go into a great deal about how or why you do that. But what I can tell you when we're adding fractions, if the bottom number is the same as it is in this case, which is 8, we keep the answer the same. So we're in 8 still. And you simply add the top two numbers. 5 add 6 equals 11. So we've got 11 8s. So if you think about it, we had 5 8s, 5 bits of something in 8s, and 6 bits on the other side. Put them both together, they're still in 8s, but there's 11 of them. As I say, if you're a bit unsure about adding fractions or subtracting fractions for that matter, we have got a separate video on working with fractions that I would recommend you go back and have a look at. So we've now got 11 8s, but there's a slight problem here in that once again we're left with an improper fraction. 11 over 8, 11 is higher than 8, is a higher number than 8, so it's an improper fraction. So we need to simplify this down, and using the same method we did before, we can work out that the 11 8s is the same as 1 and 3 8s. So 8 8s would give us our whole 1, and we've got 8, 9, 10, 11. We've got 3 left over, so we've got 1 and 3 8s. That's added up our fractions for us. We need to remember we had our 6 up here, so let's put that back in as well and add that in, which gives us a final answer of 7 and 3 8s, which is the final answer for our calculation. So if I show you that in steps, let's just get rid of the writing on the screen. So in terms of the steps, what we did there was we separated the whole numbers out and took them away. We didn't actually, we added them, but took them out of the calculation and just to make life a little bit easier for us. We then did, in this case, addition, or we could have done subtraction. And reminder, I'm not going through multiplication or division, just simply because it's not needed at functional skills level 2. But if you'd like to go through that, I'm sure your tutor could help you with that if you wanted to know how to do those. We would then simplify or convert any numbers. In the case we just had, we had a mixed fraction. So we had an improper fraction, so we converted that back to a mixed fraction. And then we put our whole numbers back in and gave us our final answer. So hopefully you can think about that pattern, that process that we took with the one there, with the example previously. So I'm going to give you one more example before we finish. And this time we'll look at subtraction. So I'm just going to change my pen. Let's go for a different color. Why not? So in this time, we're going to look at the calculation of 3 7/8, and we're going to take away 1 3/8. And what we'll do, if you can think of it or work through it on pen and paper as I'm going through, that would be useful as well. So the first stage says that we need to separate the whole numbers. So let's take them over here. We've got 3 and 1. We're doing a takeaway calculation. So 3 take away 1 equals 2. And we're going to park that on the side, and we'll come back to that in a little moment. So we know we've got rid of our 3 and we've got rid of our 1. We're left with 7 8, take away 3 8. Same principle we had, so we've now separated the whole numbers. We now need to take away in this case, and it's the same principle we had when we're adding the fractions, where we keep the bottom number the same, so we're still out of 8s. And our top numbers we just take away. So we've got 7 take away 3, gives us 4 8s. So we've now added or taken away. We now need to simplify or convert, and the correct answer for the fraction is 4 8s. However, one thing that you should always do with fractions whenever you can is simplify them to the lowest possible fraction that you can. And you can probably see automatically this one, it's a relatively straightforward example. 4 8s is the same as a half. Because there's 1 4 in 4 and 2 4s in 8, so we can simplify down from 4 8s to a half, Once again, if you're unsure about simplifying fractions, then you can watch our other webinar on working with fractions with that. So we've now simplified or converted, and the final thing we need to do is just put our whole numbers back in. So our whole number was 2, our fraction was half, oops. So our final answer is 2.5. Simple as that. Separate the whole numbers, add or take them away, simplify or convert, and then add the whole numbers back in. Now, one thing we could have done is just made this a little bit more confusing. I'm not going to go through this one now, but we will send some follow-up questions to this webinar, and we have got them, so you can ask your tutor for those questions if you don't get them. But let's say it was 3 7/8 take away, let's say we stick with 1, but 3 11ths. Why not? So now it gets a little bit more complicated because we're taking 8s and taking 11ths away from 8s, and that's a bit more complicated. But as I say, that's more to do with adding and subtraction fractions generally. That's not to do with just mixed fractions. You would still separate the whole numbers, then add or take away those fractions, simplify, convert, and add the whole numbers back in. So relatively quick webinar, and hopefully that's showing you what we mean by improper fractions, which are simply fractions where the top number is bigger than the bottom number. We would normally convert those improper fractions whenever we can into whole numbers if we can, which is great, but we may need to convert that into mixed fractions, and a mixed fraction is simply where you have a whole number and a fraction element. And we've just gone through adding or subtracting mixed fractions, and a quick reminder that the process for that is to separate the whole numbers, do your additional takeaway, simplify or convert your fraction, and then put the whole numbers back in. So hopefully we've gone through all of those, and hopefully you found that useful. Please do watch the other webinar that I've mentioned. Please do speak to your tutor if you would like some follow-up questions or follow-up questions to work on, or if you've got any questions yourself you'd like to know. And look out for our future bite-sized sessions. Thanks for listening.